Hi, welcome to my channel. In the previous video, we discussed about MNST dataset. MNST dataset. So here it contains 70,000 images dataset, 70,000 digits images. Okay, this dataset is divided into two parts. One is training purpose, training dataset, and testing dataset. Testing dataset. So it contains training set contains 60,000 images and testing contains 10,000 images, 10,000 handwritten digit images. So now our problem is whenever you are giving the any digit like it 5 or 1 whatever maybe. So when suppose you are giving the problem digit is 5, our aim is you have to classify whether it is a 5 yes or no. Okay, like that we are going to classify our data. Simply it is called as a binary classifier. So now our problem is to identify the one digit is the number 5. So this is called as a simply 5 detector. So this is the example for the our binary classifier. That means we are giving the an image for our testing data. So the testing data I automatically classify whether the data is 5 yes or no, yes or no. Simply it is called as a our binary class problem. So here our aiming is distinguish between the two classes. That is the class is one class is the S class and another class is no class. So that is a 5 and not 5 class. So you are going to create the target vectors for this classification task. So now, so here the data set is divided into two parts. One is so here the data set look like this one. The corresponding X train, and that is here the features are there. This is called as X data and this is called as a Y data. And once again this is divided into two parts like this for X train and Y train and X test and Y test. Now our aim is we are classifying these Y train data into two parts. One is whether the element is equivalent to 5 class. So that is assigned for the Y train. Okay, Y train 5. Otherwise not 5. Okay, otherwise not 5. Otherwise is not 5. Okay. So whenever giving the element is give 5, whenever we are giving the element to the handwritten digit, that is 5. So that is mapped to the class as a okay Y train 5. Otherwise is classified as a not 5. So for that we are giving the assign we are giving some label. We are giving one variable that is a y underscore train underscore 5. For that we are going to whenever we are giving whenever the elements are here we are here that is equivalent to 5, that is assigned to y underscore train underscore 5. So that is true for all 5s, false for all other digits. So now y test underscore 5 equal to y test underscore equal to 5. That means whenever that is equivalent to y test value also equivalent to 5, then that is also assigned for the y test underscore 5. Otherwise it is assigned for the not 5. Now we are going to use one classifier, and we are going to based on that classifier we are going to train our model. So here we are going to use the stochastic gradient descent classifier is there. So this is one of the best classifier algorithm to classify the given data into two parts. So here that is in the scikit-learn's SGD classifier class. So now this classifier has an advantage of being capable of handling every large data set efficiently. So that means if the data set can large amount of data instances are there, automatically in this stochastic gradient classifier works very well on that large data set. So this is part of the because SGD deals with the training instance independently one at a time. So this is the major advantage of the stochastic gradient descent algorithm. So the main advantage is it trains the instances independently only one at a time. That is the advantage of the stochastic gradient descent algorithm. So now we are going to train our model with the help of stochastic gradient classifier. So for that we are importing the HGD classifier from the sklearn.linear model. Now, so here we are creating a object for the stochastic gradient classifier. For that we are providing the value as a random state equal to 42. So that is assigned for the stochastic gradient classifier. So now our model is a stochastic gradient classifier. So for that classifier we are going to use the fit function. That means our model is stochastic gradient classifier is trained based on the x train data and y train data, y train underscore 5. That means only class label is equivalent to 5. That is trained with our model. So now the stochastic gradient classifier relies on the randomness during the training data set. Hence it is called as a stochastic. And if we want reproducible results, then we can set the random state as a parameter. So now we can use it to detect the image of the number 5. So now we are going to identify, we are giving some value to the assign that model classifier. So for example, in the previous class, we are assigned some label as a sum underscore digit. So that is x underscore I log of so y 0 to 1. That means here the first element is assigned for the sum underscore digit. Now this variable is passed at sum underscore digit. Now based on this is simply it is acting as a our x test data. Now this test data is using this x test data. We are going to predict the model. We are going to predict our classifier model. Okay. Now our after we do this program online, we are getting the value as a true. That means why it is getting true? The allocation first instant variable is in the x data set is the class label is 5. So here the original label is we are giving the features as a of 0th index, and that is mapped with the corresponding class label. So that is equivalent to corresponding y test data equal to y test underscore is 5. So both are the equivalent to 5. So that's why we are going to get the output as a true. Now the classifier guesses that this message represents a 5. That means it's a true. Now we are going to see how we are going to work with the help of Google Colab or Jupyter Notebook. Now I am opening the Jupyter Notebook. In that we are going to see the how we are going to execute our binary classifier. So here we are giving that we are assigned two variables are there. One is y train underscore 5 equal to y underscore train double equal to 5. That means whenever the value is equivalent to 5, the corresponding target variable that is assigned to y underscore test underscore 5, and remaining are not equal to 5. And y test underscore double equal to 5 also that is assigned for the y test underscore double equal to 5. Okay, so now we are going to apply our model, that is the stochastic gradient classifier, that is importing from the from the sklearn.linear model. So now we are creating a object for the stochastic gradient classifier. Okay, for that we are going to give the variables as a n underscore jobs equal to -1 and random state underscore equal to 42. So that is based on this class we are going to create an object, that is a stochastic gradient classifier. Now we are going to train our model SGT classifier dot fit function. We are applying the fit function to train our model. So here x is equal to x underscore train and y equal to y underscore train underscore 5. That is it contains only 5 elements. Okay, so now based on this one our model is going to train. Then we are going to predict the model with the help of x equal to some digits. So that means we are giving the first index value, that is 5, that is assigned for the x test. So now we are going to get the output as a true. So this simply is a equivalent to 5. Like that we are going to train our model and predict the value. So here two functions are very important. One is we have to import our classifier model. Our classifier model is stochastic gradient classifier. Okay, we are creating the object for the stochastic gradient classifier, and then we have to train our model. Okay, stochastic gradient classifier dot fit function. For the fit function, we provide the variables like training data and corresponding features and corresponding target variable. And then we have to predict the class label with the help of we are providing the only text data. So this is the way we are going to classify our data. So in the next class we are going to see the performance metrics of the different metrics for the classifications. Okay, thank you for watching our video. Thank you.